Okay. So what about 11 over 7? What is the multiplicative inverse? 7 out of 11. I love it. And then 0.03, what should you do with that first? Sorry? What happened? What's up? Sorry? So 11 over 7 is positive, so its multiplicative inverse is going to be positive also. You just flip it. So if the number was negative, the multiplicative inverse will be negative. You just flip it. Flipping something won't change its sign. Good, I like it. So 0.03 is actually 3 over 100. So what is the multiplicative inverse of that? 100 over 3. Okay. Yes, sir.
Additive, what if we change it to a fraction?
This one?
Right? Yeah.
So this is in the tenths, hundredth spot.
I'm saying I'll put decimals for both of them. I mean fractions for both of them.
Oh, sure, that's fine. Don't worry about it. So you could put here negative 300ths.
Yeah,
That's cool. These are both the same number. These are both the same number.
Yeah.
It's just that when I go to reciprocate it, I can't have a decimal inside of a fraction. So you definitely have to change it for that. But this is cool. This is no problem. Same number.
Do we have to reduce in the end?
Well, it doesn't really reduce.
Okay, so.
You can make it a mixed number, but I didn't really say to, so you can keep it like that. Yeah. All right, let's see. Let's do some more of those. That was fun. Let's do it again.
So if they don't reduce anymore, you can keep it as an imperfect fraction?
To be honest, it's a little better to keep it like this because you can see the direct connection to that. Yeah.
Okay.
All right. Well, that's going to be nice and even. I like that one already. Yeah, put that negative that last one.
Just a second.
I would start off with a decimal, wouldn't I? What's up? Oh. So what's the additive inverse of negative 11.2? Positive. That thing. Okay. Just look at you. he's like, just let me say the exact thing. The only thing that matters. Make it positive. All right. So positive 11.2.
Yep.
Now, the multiplicative inverse is going to be a little tricky on this one. Yeah. If you're having trouble on that first one, let it go for a minute. Do these definitely finish those out. Those should be pretty straightforward.
So, yep. Negative 4. Yep, negative 4.
And then multiplicative inverse of 4, what's that? Yep, 1 over 4. Alright guys, let me catch up to you. Yep, good. Gotcha. Okay, good. Let's leave this for a second. What's the additive inverse of 4? Negative 4.
Negative 4.
And the multiplicative inverse of 4?
Negative 1 over 4.
1 over 4.
1 over 4. See, the problem with this kind of setup is you guys look here to do that, but it's 4.
Yeah.
4 becomes negative 4 as an additive inverse, and 1/4 as a multiplicative inverse. So the multiplicative inverse will always have the same sign. That's the only way to guarantee it comes out to be positive 1 when you multiply. Alright, I like it. It doesn't change the sign. Negative 39 over 40. Additive inverse? 39 over 40. Just change the sign. Multiplicative inverse? Negative 40 over 39. So the negative still has to be there. You just flip it. That's all you do for
multiplicative. But we're keeping the negative.
Yeah. See, because
Right.
what's the instructions for multiplicative inverse? Flip it. I didn't say a word about the sign, so the sign doesn't change. How do you get an additive inverse? Change the sign, right?
Yeah.
2 different things. I like it. So with this guy, the additive inverse easy. What's the additive inverse of negative 11.2? 11.2. Multiplicative inverse, oh, scheisse. German cussing is always good to know how to do.
11 and 2 tenths.
So I like it. So it's negative 11 and 2 tenths, which still sucks. Because I don't want, if it was a single improper fraction, I could flip it real easy. So how do I make this into an improper fraction?
Multiply and
Yeah, 10 times 11 is 10 times 11 is 110. You just add a 0 at the end. That's how you multiply by 10, right?
Yeah.
10 times 11, 110 plus 2? 112. So that's a negative 112 over 10. So what's the multiplicative inverse?
10 over negative 10.
Negative 10 over 112.
112, yeah.
Which you could reduce. I don't really care.
Right.
I like it. All right. I like it. Amen. So really today we talked mostly about terminology. You already know how to reciprocate numbers. You knew that. You already know how to change the sign of a number. You knew that. Now it's just we're going to call this additive inverse when you change the sign. We're going to call it multiplicative inverse when you flip it over. It's just the words really that's new. Okay. Oh, okay. So the last little piece, let's see. 0, of course, is a weird little dude. I can't remember. I think I already talked about this because it's a weird thing to talk about. But what happens? Well, to start off, it should be nice. What is 0 divided by 4?
Undefined.
I got like 3 different answers, so it's got to be something. Yeah, it's 0, right? And you can think about it physically as if I got no money, and there's 4 of us. How much money do we each get?
We ain't all got no.
Nothing. So if I got something to divide amongst 4 people, that could be captured as that thing divided by 4. So if I had 8 apples and there's 4 people and I'm a nice guy, fair, I'm going to give each of us 2 apples. 8 divided by 4 is 2, right? That's like the physical definition of division, is you're dividing it amongst people. So if I got nothing and there's 4 of us, hey, each of us gets nothing. Yay.
But I thought you could divide by 4.
Second, you can't divide by 0, and I'm divided by 4.
How?
I like it. And mathematically, why does this make sense? The answer has to be the number that when you multiply by 4, you get 0. And what's 0 times 4? 0. Because what is 6 divided by 2? 3. Because 3 times 2 is? That's why 6 divided by 2 is 3. Because 3 is the number that when you multiply by 2, you get 6. Oh my God. So, the physical interpretation of this is very strange. I'm not going to start there. I'm going to start with the mathematical interpretation. The answer has to be the number that when I multiply it by 0, I get 4. The same way this was 3 because I multiply by 2, I get 6. Are you guys with me? What number do I multiply by 0 to get 4? Is there a number defined to do that? No, so it's undefined. That's why we call it undefined because there's no number defined that when I multiply by 0, I get 4.
So it's unreal.
It's not unreal.
Not real.
That's no, because that would mean it still could be defined. There are not real things that are still defined. So undefined is somehow even worse than that. I like it.
Can't win.
No, you're one step away from winning. Real quick, just to do a few more of these. 10 divided by 2 is 5, because 5 times 2 is 10. 20 divided by 4 is 5, because 5 times 4 is 20. 4 divided by 0, no. Because nothing times 0 is 4. There's nothing that's defined. When I multiply it by 0, how can I get 4? It's always going to be 0. So I don't know if you guys, I'm pretty sure I talked about this earlier, maybe not, but the idea of undefined, I'm sure most of you guys have heard that word, but I don't know if it's ever been explained to you why we use that word. That's why. There's nothing defined to do what this guy wants it to do. Physically, what does this mean? All right, this is freaky. It should be freaky because it's undefined. What if there were four apples, but there's nobody there? How much does each person get? There's nobody there, right? This is, I got nothing but 4 people. This is, I got 4 apples, but nobody, not even me. I'm not even there.
Nobody.
All right, do you guys follow? I'm not trying to make this confusing. The physical interpretation has to be weird because the answer is freaking undefined. So that is the physical interpretation. I got 4 apples, but nobody, not even me, is there. Well, that's undefined. What? Maybe. This would be, I got 20 apples and there's 4 people, so everybody gets 5 apples.
So
right?
makes it defined.
This is defined. What number is defined to multiply by 4 to make 20? 5. What number is defined to multiply by 2 to get 6? 3. What number do I multiply by 0 to get 4? Undefined. There's no number defined to do that. I just watched Doctor Strange. You see 50 others. I need to find out what cloak of less confusion or something. That's the one. I got to get you guys to take off the cloak of confusion. All right, let me see. Okay. Let's make sure I hit everything in there. So let me ask you this: so if I said what's 0 divided by something, what's the answer always going to be?
0.
0. Thank you, Dee. 0 divided by something is going to be 0. So what is 0 divided by negative 11 twelfths? 0. Who gives a crap what I put here? Right? So what is 0 divided by the square root of 14.298? 0. Okay. They're not going to do something crazy like this, but they do this in a few places. Don't make this too much of this. And what is anything divided by 0? Undefined. Careful. I can't divide by 0. It's undefined. In some movies you might see it's referred to as the singularity. Right? This is somehow related to black holes and stuff, so that's some weird shit. Okay. So whatever I put here, it's going to be undefined.
Because 0 can't be divided by
Into a number, exactly.
Into a number.
Watch this. Try to do what that says. Try to do it by hand. 0 into 4. Okay, what number do you put here?
4.
0 times what is 4? I can't even start it. Do you see that? I can't even start it. All right, I like this. That's what. Huh? Jackie's like, no. I have mega 0. Mega 0. That's what I wanted to do. Mega 0. Make it 4. Just math. Jackie's a direct controller for math. But, do you guys understand? I like this. I didn't even think about doing this. You can't even get this thing started. Please, dear God, don't write that down. It's not true. There's no mega 0. You can't even get it started. That's why it's another reason why it's undefined. Okay. So, this last idea in chapter 7. So that was 7:4. This is 7:5. Does anybody still need a copy of chapter 7? I've got a couple. Everybody's got chapter. Oh, here's.
And she wants more.
All right, guys. Let me see what you guys know already about units. Does anybody know? What's up? Does anybody know how many inches are in 1 foot? 12. Okay, good. Thank God. If you ever looked at a ruler, you know this to be true. So 12 inches in a foot. All right. Anybody know how many feet in 1 mile?
That's good.
3,000 something.
5,000. 5,000 something.
5,000 something.
I don't even know what it's like.
5280. All right, Nita. Oh, how many feet in a yard? 3 feet in a yard. I like it. I mean, these are things you definitely. Now, this middle one, I kind of understand if you don't know that right off the bat, but you gotta have a feel for it. So I appreciate the estimate, Jesse. You gotta have some feel for it. There's a lot of freaking feet in a mile. 3 feet in a yard, you gotta know. 12 inches in a foot, you gotta know. It gets really weird when you start talking about gallons and pints and cups and quarts and oh crap. Right? So let's just use what I've got up here to do a couple of example conversions. I'm not going to try to convert you to mathism or something, but conversions just in length here. So here's the idea. This is kind of nifty. I can make this up as I can write this as a ratio, right? For every foot there is 12 inches. So I could write 1 foot to 12 inches, or I could write 12 inches to 1 foot. Right? Now think about it. 1 foot is 12 inches. So what's the value of this fraction? 1 foot divided by 12 inches. 1 foot is 12 inches. So what is 1 foot divided by 12 inches? 1. I love it. So if I multiply something by this, will I change the value of it? Because what is this again? What's the value of this? This is 1. These are both 1. So if I multiply something by this, will I change the value of it? When I multiply by 1, what happens? Yeah, the identity stays the same. That's what we were just talking about. So if I multiply something by this ratio, the value stays the same. So, if I have 47 inches of lumber, and I need to know how many feet that is exactly, I want to show you the process. It's kind of nice. It really comes down to, do I divide by 12 or do I multiply by 12? Really, it's what it comes down to. But the way to actually have it done for you is this. So what did I say? I want to take this to feet, right? I want to take that to feet. So what I do, so what units do I not want there anymore that are there currently? Stupid inches, right? I don't want the inches there. Does that make sense? I want to replace the inches with feet. So watch how this works. Here's 47 inches. Oh boy. If you ever took chemistry at all, this is going to look very familiar. Now, don't worry about it. I'm not going to bring in Avogadro and all that stuff and perfect, ideal gas law, shit like that. No. This is way better than that. So what unit do I not want there anymore? Inches. So where will I put inches so that they will cancel?
And then replace them.
I put them here, don't I? Do you see how the inches will cancel? This is sort of related to the unit question I had earlier today, which I appreciated because it led right into this. Everybody see how those inches are going to cancel? If I put it there, I'll get square inches. I don't want freaking square. I want feet. So on top I could put feet. So which one of these am I going to use? They're both valid. Which one, of course, will I want to use this one? And all I really got to do is say, where does what number go? Well, 1 foot has 12 inches in it. So now, what does this tell me to do? It just tells me to divide. If the number's on the bottom, I divide it. The numbers on the top, I multiply. You gotta love that stuff. This is what's called unit analysis. The units, you see how I didn't put any numbers up at first? I just analyze it. I don't want you anymore. Die. And then replace it with what I want. Right? So then what is 47 divided by 12?
So you don't cross multiply?
3.8333. What is it?
You divide.
No, is there an equal sign in the middle? No. This is 47. This really, I like doing this grid kind of thing, but just realize this is 47 times 1 over 12. 3.8333. No, 3.9.
3.9. 1.
Okay. 3.91 feet. Or 3.9 feet, whatever I tell you to round to. What's important here is the process to get you there.
So you said if something's on the top, you divide, and then wait, what has to be on the top again? I'm sorry.
All right, you ready? So here's what if I instead? Oh crap! I want to take that home. For me. So what was it? 1 foot is 12 inches. 1 yard is 3 feet. 1 mile is 5,280 feet. Yeah. Just want that up there to reference. So what if instead I said I've got what you got, Jim? I don't know, Jim. 9.2 yards, and I need to know how many feet that is. Now again, I'm not telling you that if you already know what to do here, you can just do it. But if you're not sure what to do, you can always set up this unit analysis thing. So if I got 9.2 yards right now, what do I not want there anymore? Yards. So where are you going to put it? Down here. And then feet, I want feet to show up. So yards die, and I replace it with feet. Now put in here where the numbers go. What's the conversion between feet and yards? Yeah, 3 feet is 1 yard.
Oh, yeah, you're doing yards now, not inches.
Yeah, I'm doing yards now.
Right.
Crazy.
So you multiply.
So then you multiply. I like it.
I don't understand how you determine that. Because the feet's on top? Or
Because the 3's on top. So what's it say? 9.2 times 3 over 1.
1.
So it's 9.2 times 3 over 1.
Okay.
So you multiply by 3. So I could write this like this.
So
Right.
we
That looks better.
multiply in the 1.
All right. Let's do this. You guys help me out.
How it's yards, right? The yards are equal to feet. You just divide it by 3.
Multiplying the 1
Just make it harder.
over 9.2.
Here, guys. How do I do this?
Just make it harder.
Jackie, if you got a way to do it that makes more sense to you, you can do it that way.
No, but she doesn't understand why you divide it by like that. Because it equals.
I'm
the
saying I
yard
don't
is
understand
one.
how you get the dividing and defer.
Yeah, okay, good. So how would I do this? How would I simplify this problem?
Multiply 3.
Yeah, multiply by 3. Why would I multiply by 3? Because it's on the top. And I would do what with the 4? Divide by it. Why? Because it's on the bottom. That's all. We already know this. So here, why would I multiply by 3? Because it's on the top. Divided by 1 is not going to do anything to me, right? Divided by 1 just keeps it the same. So all I got to do is 9.2 times 3. So that's the units. The units tell you where to put the numbers. So let me do 2 things. Let me do another problem just like this, and then let me explain what's happening in the background here a little bit more explicitly, right? So real quick, just to finish this one off, 9.2 times 3, 27.6 feet. That was the winner. That's the one that left alive, right? All right, now, immediately I want to do one going the other way. What if instead of yards to feet, let's say I have 11 feet, and I want to know how many yards that is. I want you to really see what's important about this process. 11 feet, that's what I got right now. What do I not want? Feet. I want to replace that with yards. So where will I put the feet? On the bottom, because they're right now on the top. See how that, they'll cancel now. They'll get out of the way. And now I can replace it with yards. So you're sort of like invasion of the body snatchers, right? You're replacing these things with what you want. Now look at the units. Where does the number 3 go now? I mean, what's the conversion? It's 1 yard, 3 feet. So what do I write next to yard? 1. What do I write next to feet? 3. The 3 was on top here, because that's where the feet were. 3's on the bottom here, because that's where the feet are. Right?
So you divide.
Yes, good. So you just divide. 11 divided by 3. And you get 3.66666. Alright, let's do another one. Again, I appreciate how you guys want to be able to understand everything the minute you start looking at it. You kind of let it sink in the brain a little bit. Right? So let's do some more. Let me explain this in the background though. If 1 yard, so if I have a yard, what I'm really doing is I'm cutting it into 3 pieces, and each of these would be 1 foot. Let me stop there for a second, right? If I had a foot, and then another foot, and then another foot sitting next to each other, I can combine all those and make 1 yard out of it. Is that cool? So if I had 4 yards, I can break each one of those into 3 pieces. So how many total pieces would I have? 4 times 3. I'd have 12 feet. So when the unit I'm working with is bigger than the unit I'm trying to go to, I'm going to multiply. I try not to teach it that way because I think you're just kind of memorizing that, but that basically works. If I got a bigger unit, the yards are bigger than feet. So each yard can be broken into 3 parts. So every yard has 3 feet. Every yard has 3 feet, so 4 yards must have 12 feet. Each one of them has 3 in them. So that's really behind the scenes of this is what's happening. So if I set this up 4 yards, then I want the yards to go away and replace it with feet. Right? See, the yards go away now. If I put the yards on top, they wouldn't cancel. That's all. That's the key step there, though, is to realize the units going in the right place is what tells you where to put the numbers. So what do I put next to yards? 1. 3. So now this tells me to multiply, like we said earlier. I like it. Coolness. So we've been through this kind of thing before. We always talk about something that looks so weird, then you got to let it sink in a little bit.
Yeah, you just get,
and then it's not quite as weird.
The yards and stuff like that, but it's
I like it.
almost like cancellation and all that.
Exactly. That's really all it is. All right, now watch this. Here we go. Oh boy. All right, Jeff. So, let's say I got 0.8 miles. And I want to know how many inches that is. Wow. All right, now don't freak out. Every problem we've done so far was a one-step problem. Now, how do I get from miles to inches? Do I know anything directly from miles to inches? No. So how do I get from miles to inches? I can go from miles to what?
Feet.
I can go from miles to feet. And then from feet, I can go from feet to inches. That step right there, figuring out the path you're going to take, is the step that students skip all the time. And then they make really neat mistakes. And they end up saying like 5 miles is the same thing as 2 inches, and that's freaking me out.
But
whoa! Yes?
you don't have a 4 mile though, so.
That's all right. If 1 mile is 5280 feet, half a mile would be 2640 feet. Or what was it, 2690? 2190? Do you understand? So 0.8 miles is going to be a little less than 5,280 feet.
4,000 and change.
And again, you can use your calculator for this. We're past the point where I'm going to make you show me the decimal multiplication. Yeah. So the whole thing to start us off, I'm at 0.8 miles right now. Following my path, what do I want to get rid of and what can I replace it with? I want to get rid of miles, so where do I put that? On the bottom. and I want to replace that with feet.
Yes.
Because I can't go directly from miles to inches. I don't have that conversion. But now see if you can just watch. Have I gotten to the unit that I want yet? No. So just keep going. What do I want to get rid of?
The feet.
Feet. So where are you going to put them?
Bottom.
Bottom. And now I want to go from feet to inches. Now you don't have to cross these out like I'm doing. I just want to make sure that you understand that all these get out of the way and inches are left at the end. So now what goes next to these? What do I know about feet and miles? What goes next to miles? 1 mile is 5280 feet. 1 foot is 12 inches. So what do I do with all these? Multiply all of them because they're all on the top. Anything on the bottom I divide by, which, we already know that. Anything on top I multiply. So whatever the hell that comes out to.
50,000.
Just gonna try. What is it?
50,680 inches.
680?
88.
88? So you guys got? Just throw that in the old calculator.
Close.
Close.